I'm Brad. I work at Craigslist. I joined Craigslist in 2015 after spending about 4 years working at Booking.com, where I helped build the security team there. We leveraged a lot of Elasticsearch in that role. I got to break Elasticsearch in amazing ways. And I'm really proud to be working at Craigslist because we highly value our users' privacy, which is kind of a rare thing to find these days in a company. We will not make money over our users' privacy. We hold that very, very true. We wanted to add in some additional tier 1 rate limiting features into our front end. We wanted to do this to protect our users, and we wanted to do it in a way that wasn't going to break our site for any legitimate users. So my boss and the CEO came to me and said, this is what we want to do. Would you be interested in doing it? I said, sure, let's give it a try. So the requirements were pretty simple. Fail open, always leave the site accessible if something is wrong in the back end. Don't impose any latency penalties on clients at all. Make sure that any and all components of this system are maintenance safe. We're a very small team, so time spent doing maintenance needs to be as small as possible. We run our own data center and servers, so this happens frequently. We need to upgrade firmware to replace hardware, so it needs to be maintenance safe. And again, this was just a tier 1 rate limiter. If you're not really familiar with that, that's just kind of a speed limit. It's not doing any kind of fancy analytics yet. All it does is say, you can only go this fast on this highway. We only had 1 month to implement this project, so that was intentional to keep it as simple and straightforward as possible. If you go to the internet right now and search building a rate limiter, there will be one resounding technology that will show up in every single example. Everyone uses Redis for rate limiter implementations. There's really rich primitives, data primitives for doing rate limiting, so it's a great choice. So why not just do it in Redis? Might look something like this, where you're using sorted sets. You add data into that sorted set, and then you set the expiry, and then you count how many things are in that data set greater than the timestamp that you're looking at. You can do all this in a Lua script as well to limit your round trips to Redis to 1 instead of having to do 4 separate operations. So you could put this kind of implementation in a critical path, and that's what it's designed for. So right at the end, we're done, right? We just build it with Redis. Unfortunately, our experience with Redis is not like what you've seen in the movies. There's a lot of weird maintenance issues that we've hit where we will reboot a node in a Redis cluster and some weird latency spike hits the front end. And being that we have a small team, I didn't want to introduce any additional weird latency issues. The proof of concept for doing a rate limiter with Redis was pretty simple and straightforward, and it was built in a day and it worked. But the idea of scaling that and making it so we could arbitrarily take one node down, bring it back up, take another node down, bring that node back up, and not have any weird data issues just didn't make sense in our infrastructure the way we were using Redis. And that meant if we wanted to use Redis for this, we would have to essentially create a new Redis architecture. What I did was kind of zoom out a little bit. When I did work at Booking, we learned that 90% of our ideas were either directly harmful or completely made no difference whatsoever to our users through our experimentation tool. So the takeaway I got from that was have a lot of really bad ideas, because the good idea is hiding as 1 of 100. So you got to have 99 really bad ideas before you can have a good idea. So I'm not afraid to propose something counterculture. I wasn't jazzed about Redis. I knew it would be a lot of work to implement a Redis clustering solution with our existing infrastructure, and it would probably be just as much work to stand up a new technology. And I heard a lot of great things about ClickHouse. We have these maintenance issues with Redis. I was very interested in ClickHouse. I'd been hearing a lot about it in the security and observability spaces. There's a project called Zeek. Some people have probably heard of it. They've been doing a lot of really interesting stuff with ClickHouse. I work a lot with Graphite, and the Graphite project actually has Graphite ClickHouse and Carbon ClickHouse for using ClickHouse as a backend with amazing results in all of the demos and things that I've seen. So I was starting to get really interested in ClickHouse. We had an existing stack of these access logs coming in to a Kafka topic, and then there was some code, and they put them in Elasticsearch, and they did other things with them. And we already had a rule injection layer at our ingress point that already had an ACL API. So the thought of adding a second ACL API on top of that was like, well, then if somebody gets blocked, which layer is actually blocking them, and why do we have two layers? It didn't seem like the right thing to do. So whatever solution we came up with, we probably wanted to reuse that existing ACL API that we already had available. So that gave me a lot of freedom because I did not have to do the rate limiting directly in the endpoints. I could just have something push rules into the front end. I asked my boss, like, what do you think of this idea? Maybe I can try this with ClickHouse. And he was like, well, I've been really interested in ClickHouse as well. Let's see what we can do. So we already had the Redis proof of concept put together. It worked. And I asked my boss, like, let's do this in a week. Let's just spend a week on it. If we get nowhere, then we get nowhere. And we just go forward with the Redis solution, and we don't really lose anything. So all we have to do is start from zero. There was no ClickHouse in our infrastructure, so all greenfield. After we got ClickHouse running, I had to get data into it from Kafka, which in order to keep in line with the rest of the tooling, I wanted to go through the same libraries that we were using for the rest of the stuff coming off of Kafka, which meant standing up a Perl daemon to do that and using some Perl libraries. Then once that was done, sure, I had this thing that fed data into ClickHouse, but I want to be able to do maintenance on that node now, so I need to reboot that node and see what would happen. I told my boss if my goal was to have a ClickHouse cluster where I could take any node down, destroy all of the data on it, restart it, bring it back up, and have it join the cluster with no impact to clients. And he said, and you're going to do it in a week? I was like, I hope. So it's not sexy and cool, but Craigslist, as you can tell, isn't sexy or cool. We use boring technology. There was a Perl daemon that reused some Perl libraries to cram the data into ClickHouse. That worked really well. I put together another daemon that would translate rules into ClickHouse queries that could then take the results of those queries and inject them into that ACL API. The other fun piece of this was because I kept all of the field names and data structures very similar, I was able to drop this into all the rest of our observability tooling. So it made the project very observable, and people could actually see how the rate limiter was making its decisions by clicking on a rule that had fired, and they would be able to view that. So that was a lot of fun. I am a complete newbie when it comes to ClickHouse. So a lot of you are going to look at this and go, this is the wrong way to do it. And I already know that there's horrible mistakes made in the table structure that we're using right now, but this is kind of a prototype, tons of room for improvement. I've learned since then using Codex for doing better compression and performance on certain column types. Functionally, this is missing a lot of the business dimensions that we would have in our data. That's just, specific to us, and won't be specific to you, but you can imagine having user ID or customer ID, geographic region, things like that in the access log data. Here in blue is, how you do a replicated merge tree, nothing new to anyone. I was really impressed with the partition capabilities of being able to partition out on data inside of each row and then using that to inform the age of the data, because that's something that I use a lot in Elasticsearch. So finding the ability to say, keep 2 days worth of data and me not have to touch it, that's really awesome. So that's what the red and the orange things do there. When I started out building a project, I usually start at the configuration file because I help shape the way project is going to evolve. I want to see what knobs I want to turn even before I have the daemon designed. So this is kind of like a simple sample rule from the rate limiter where it uses using the IP address as an identity. That'll be used in the query to create the group bys. The query actually says, select these rows in the data set, and then we have an allowed of how many are allowed per minute and per hour by each IP address. And then there's a block designation that says how long to block for and what dimension to block on. So in this example, this is saying don't allow credential stuffing, which is something that, happens on a lot of sites all over the place. So based on that rule, all the daemon does is translate that over into a ClickHouse query. So it's going to end up using that IP as the identity to group by, and then we're going to apply the query parameters here to make sure that we're only getting the post requests to the login page, and that for this particular example, this is the past 60 seconds. And we said in the rule that it would be anything more than 3. So this will give us back a list of IP addresses as well as the number of hits, so that we can take that to our ACL API and dump that in there and say, block this IP address. In this setup, this will actually, the way that this rule is written, this would actually banhammer that IP address for 15 minutes, because we don't have any additional specifications in the block by. If we had a cookie issued, content scrapers don't tend to want to spend many resources on their side, so they will skip any type of persistence on their end and just favor querying over and over again. And so when you have a really low-level scraper, they're constantly getting issued new cookies. So in this case, we could actually look at a place where we have sensitive data and say, if we have this is coming into a sensitive data endpoint and we're issuing a new cookie, we only want to do that. We only want them to be able to do that once per minute or 6 times per hour. This is just an example. We don't actually use this rule right now. But what this allowed me to kind of work out in my head is the block by then allowed the ACL API to add in these parameters. If you were a regular legitimate user and you were hitting this and you had your cookie, so you weren't getting a cookie issued, you wouldn't be counted. And then even if your IP address was blocked, you wouldn't be blocked because you would already have a cookie issued, so you wouldn't hit these parameters. So that was a lot of fun. So how did it go? Well, I mean, I'm here talking about it, and this isn't a Redis meetup. So you can kind of imagine it went really well. The biggest challenge was for me as someone in operations perspective is availability. I said that I had set a hard requirement that we should be able to take a node down and reprovision it and bring it back up and have no impact whatsoever. And I can say that that is the case. We just run a very simple mirrored pair in each data center right now. And I can run our provisioning playbook that will shut that host down, wipe its disks, rebuild it, bring it back up, and nothing in the architecture notices that that host is gone. And as it comes back up, ClickHouse performs perfectly. The queries that come into that node are handed off to the other node until it's caught up. Rules are created and everything works, which is great. From my perspective, this is a huge win over the existing Redis infrastructure. The performance is also amazing. I'm using about 20% of the indexing clients to push data into ClickHouse as I am for Elasticsearch during normal usage, which is really awesome. And the reads are fast. It's all the queries are finishing in under 100 milliseconds. There's plenty of room for improvement there, obviously. But it's giving us that free form capability to be able to create any query we want and use that in a production system, which is really nice. It's a little slower than Redis, but again, Redis is kind of cheating by instantiating that data set up front rather than what I'm doing, which is doing aggregate queries on the data in real time. But it is so much faster than Elasticsearch. So what this means is that the entire rule set can be recalculated essentially once every 5 seconds. So I can redo the entire query pool every 5 seconds. That's fast enough to catch almost everything that we want to catch. And yeah, it's not perfect. There's tons of rooms for improvements, but I think the best part for me is it's been running untouched for nearly a year without any kind of alert coming off of those systems, which is a dramatic improvement for over the Redis infrastructure. There are drawbacks. This isn't instantaneous. It's not in the critical path, so we have to wait for the access log data to come in first. So we can't block a first request. Again, this is a tier 1 rate limiter. Blocking a first request was never a requirement. So that's fine. The data set is larger than it would be in Redis because we're storing the entire access log data set in ClickHouse and not, just instantiating the pieces that we need for the rate limiter. And it's not really for critical path, right? We couldn't put these ClickHouse queries as they are now in our critical path because they take a little bit too long. But all that's okay. We get a lot of flexibility. Creating new rules is just updating a YAML file. It rereads its configuration every time it runs an iteration. So we can change things and we can demo out those rules before we actually go live with them and see what does this look like when we put this rule in place and we're at peak traffic. And even though the size is larger than it is in Redis, the nice thing about it is is consistent. We know how much space we need over 2 days of data. That doesn't really change that much. It changes slowly, so we can keep adding new rules, and we don't have to worry about, are we going to out of memory the Redis cluster by tracking this much more data. Yeah, so that's kind of the high level overview of how we're using ClickHouse for rate limiting. Like I said, I'm new to all this, so I apologize if this was not as technical as you wanted, but I did want to just say, I am learning about this stuff. There's a lot of great resources out there, but I would specifically love to hear your experiences, mostly in operations, monitoring, management, cluster sizing, that kind of stuff, because the cool, sexy queries and performance always end up getting the spotlight, and that's great, but I have a small team, and my primary goal is putting out architecture that just works and doesn't need a lot of hand-holding. So yeah, please share your experiences as blog posts or talks here. I can say that, no one's thrown me off stage or thrown anything at me. So this seems to be a really awesome crowd to talk in front of. And I am way underqualified to be talking about any of this stuff. So yeah, feel free to give a talk here, and I will gladly support you in that. And if you want to find me, this is where I am.